Okay, we're going to take a look at how to find the length of a curve. So if we zoomed in on a very small section of a curve, we could call that very small change in the length ds. And we have our x component and our y component of that change along the curve. So we end up with a right triangle here. Using the Pythagorean theorem, ds squared equals dx squared plus dy squared. Take the square root of both sides. And then we could integrate, because if we add up all of those little tiny lengths ds, that would give us the entire length of the curve. Now we need to get dx out from underneath the radical. So if we multiply by dx squared over dx squared, and then simplify, we can take the square root of dx squared, and we can take that out to the outside. So the length of the curve ends up being the integral from a to b, those are x values, of the square root of 1 plus dy dx squared dx. All right, so let's say we have y equals negative x squared plus 9, x goes from 0 to 3. We want to find the length of this curve. So we need to find the derivative of y with respect to x, that's negative 2x. The length is the integral from 0 to 3 of 1 plus dy dx squared dx. So replace dy dx with negative 2x. We get this integral of root 1 plus 4x squared dx. Turns out this isn't anything that we know how to integrate by hand, so we're going to go ahead and use the calculator. We get an exact answer, which comes out as a decimal approximation of 9.747. And if we just want to confirm that this answer makes sense, we could look at a straight line, which we would assume is going to be a little bit shorter than the length of that curve. We could use the Pythagorean theorem, 9 squared plus 3 squared equals c squared, and we get a value of c of 9.49, which is just a little bit less than the 9.747 that we got. So we can be pretty sure that our method worked. All right, now just to get a little bit of practice with our calculator, it can do all of the steps in one. So not only can we evaluate the integral, we can also tell it to take the derivative. So this is the same problem, just letting the calculator do all of the work for us. So we're telling the calculator to take the derivative of negative x squared plus 9. Now clearly we know how to do that by hand, but if you had a more complicated function, this might be a really useful thing to do. And we get our answer out from there. All right, let's say we want to find the length of x squared plus y squared equals 1. Now you could use geometry here, realizing that this is the equation of a circle. But if we're just looking at the top half, we could express this as an equation, y equals root 1 minus x squared, and we could use our formula to find arc length. And we end up with 3.1415, which is pi, and that's what we would have expected as the circumference, or half the circumference of a circle. All right, now here we have x equals y squared, and we want to find the length from y equals 0 to 3. So everything here is in terms of y. We can still use our formula. Rather than dy dx, we have dx dy. Rather than dx, we have dy. And our limits of integration are y values instead of x values. So basically, everywhere we have an x, we change it out for a y. The derivative of y squared with respect to y is 2y. Plug that in, and we can use the calculator to evaluate.